Sketching the graphs of functions, Part 1. The important features of any graph include the general shape of the graph, example, the graph of a quadratic function, so that's U-shaped or N-shaped, for example. The point or points where the graph crosses the x-axis and the y-axis. The turning points of a quadratic and cubic graph. Linear functions. The graph of the lines such as y is equal to 2x minus 4 can be drawn by finding the points where the line intersects the x and y axis. So by letting x equal to 0, y will become 2 multiplied by 0, so swapping that x for a set of brackets and putting 0 into it, and 2 times 0 minus 4 is just minus 4, i.e. y is equal to minus 4. So 0 comma minus 4 is going to be 1 point on the graph. So 0 comma minus 4 is where our graph will put the y-axis. Now letting y equal to 0, we replace that y with 0, so we have 2x minus 4 is equal to 0, and solving for x, we get 2x equals 4, and then x is equal to 4 divided by 2, which is 2, so x is equal to 2. So 2 comma 0 is another point on the line. So 2 comma 0 is that point on the line where it crosses the x-axis, and then joining them together and extending them forms our line. Quadratic functions. The general form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. When a is greater than 0, so positive x squared value, the graph of f of x looks like this, so U-shaped. When a is less than 0, so ax squared is minus something x squared, the graph of f of x looks like this, so N-shaped. So when we have a U-shaped graph, so a positive x squared graph, the lowest point of the curve is called the minimum point. So this would be the minimum point of the curve. And when we have an N-shaped graph, so a minus x squared graph, the highest point of the curve is called the maximum point. So this would be known as the maximum point of the curve. To draw a rough sketch of a quadratic function, we require the points where the graph intersects the x-axis and the y-axis, and the turning point of the curve. The turning point can be found by either of these methods, expressing the function in completed square form or using calculus. This will be shown in Chapter 3. Here's an example of how to express a quadratic function in completed square form. So if we have x squared minus 8x plus 9, so here's our quadratic function. So we're going to add and subtract half the coefficient of x to be squared. So half the coefficient of x is going to be minus 4, because half of minus 8 is minus 4. And minus 4 squared gives us 16. So we add 16 and we subtract 16. Notice that the positive and negative 16 comes after the minus 8x. And then the plus 9 is brought down at the end. This is important. So x squared minus 8x plus 16, that can be factorized as x minus 4 times x minus 4, which is x minus 4 to be squared. And then minus 16 plus 9 is minus 7. So all we've done is rewrote x squared minus 8x plus 9 as x minus 4 to be squared minus 7. And if you were to multiply this out and simplify, you would get back to the start, x squared minus 8x plus 9. So the turning point is 4 comma minus 7. So we take the value inside of the brackets, we take the positive value. So this is our little rule over here, our function. So for the function y is equal to k times x minus p to be squared plus q, the turning point is p comma q, and the minimum value is q. So following this format, we have 4 represents the p. So the 4 inside of the brackets becomes the first part of our couple. This is a minus, but we just take the positive part. If that was a plus, it would be a negative. So just to note, if that had been plus 4, then we would put a minus 4 inside the bracket. So it's the opposite sign. But the y value remains the same. So in this case, the y value was minus 7. or the y value is minus 7 because the number at the end stuck onto the brackets that were squared is minus 7. So that stays the same, the sign does not change. And in terms of our little formula over here, that's the q. So plus q remains q, but the p becomes the opposite sign. So the turning point is 4 comma minus 7. So that would be the minimum point of our graph, our U-shaped graph. And the axis of symmetry is x is equal to 4. So that's our mirror line, our axis of symmetry, x is equal to 4. And that makes sense because if our minimum point is 4 comma minus 7, 4 on the x-axis must be where our line of symmetry or our axis of symmetry goes through, because that's the middle point of our graph. Note, calculus will provide a quicker and easier way to get the turning point of a quadratic graph. So this is not in the formula book. So if this is the method that you want to use, I would suggest learning it off. But as I said a second ago, calculus, which you may or may not have covered yet, depending on what way your teacher is teaching this. If you're in my class, you have not covered calculus yet. But when you do cover calculus, it's a quicker way to do it. So there wouldn't be a need to learn this off if that was the case. By finding the points where the curve crosses the x-axis and y-axis and the turning point, sketch the graph of f of x equals minus x squared plus 4x plus 5. So we start with minus x squared plus 4x plus 5. We're going to factorize out the minus so that we have a positive x squared inside the brackets. So then we're going to complete the square with what's inside the brackets. So we're going to add and subtract the square of half the coefficient of x. So the coefficient of x is minus 4. So minus 4 halved. So that's going to be minus 2, and minus 2 to be squared is 4. So we're going to add and subtract 4, and then we're going to bring down the minus 5. So it's important to note that the plus 4 and the minus 4 go directly after the x. So the minus 4 and the minus 5 will simplify to minus 9. And we're going to take the three terms at the front, so x squared minus 4x plus 4, and we're going to factorize them. So factorizing x squared minus 4x plus 4, we get x minus 2 times x minus 2, which simplifies to x minus 2 to be squared, and we bring down the minus 9. And don't forget your minus at the front. Then multiplying in the minus, so we don't actually have to multiply it into the brackets, we can just stick it onto the front of the brackets. And then minus 9 is plus 9. Therefore, the turning point is 2, 9. So we take the number that's in the back of the bracket and we change the sign. So minus 2 becomes positive 2. And then the number that's stuck on at the end, which is plus 9, that just stays as plus 9. So that's the turning point. To find where the curve intersects the x-axis, we solve. So we have minus x squared plus 4x plus 5. So it's given in the question. Multiplying across by minus 1 to get a positive x squared. Then we factorize. And then we solve. So x is equal to minus 1 and x is equal to 5. Therefore, the curve intersects the x-axis at x is equal to minus 1 and x is equal to 5. To find where the curve intersects the y-axis, we let x equal to 0. So we have y is equal to minus x squared plus 4x plus 5. So again, that was given in the question. So we swap each of the x's for zeros with brackets. So we end up with y is equal to 5. Therefore, the curve intersects the y-axis at 0, 5. So if x is 0, then y is 5. So 0, 5. So to summarize, the turning point we worked out to be 2, 9. We know the curve intersects the x-axis at minus 1 and 5, and it intersects the y-axis at 0, 5. And we know that it is n-shaped because it's a negative x squared. So we draw our graph. So this is my x-axis and this is my y-axis. And I don't need to go any bigger than 5 and any smaller than minus 1. And on the y-axis, I don't need to go up any higher than 9. So then I plot the important points. So 2, 9 is the turning point. So that's going to be the maximum point of our N-shaped graph. We're going to have the curve intersecting the x-axis at -1 and 5. So we have a point, a red dot, at -1, 0, and 5, 0. And we also know an extra point on the graph is 0, 5. So that's 0, 5 there. So we just do a rough graph, putting those points together, and it should be fairly symmetrical. Mine's not perfect, I know, but it should be symmetrical. And quite important is that it should have a N shape at the top, not a point. Okay, so it shouldn't be pointed upwards, it should be curved. That's very important with quadratic graphs. They should be curved, not pointed. And also the mirror line is going to be the line x is equal to 2, because we have an x value of 2 at the turning point, at the maximum. So the mirror line is this line here, x is equal to 2. So you should have the same shape on the left of this mirror line. I know it's an invisible line, but if you can just imagine a mirror line, so a vertical line running through x is equal to 2, there should be the same shape on both sides of that line. So that should be a reflection of either side. So note, if f of x equals minus x squared plus 4x plus 5, then the derivative, so we have f of x, but in between them we have like a little apostrophe symbol. So this is in calculus, so if you haven't covered this yet, don't worry. But just to link it in while we're on this topic, the derivative is minus 2x plus 4. So where did that come from? So the power comes down in front. So the 2 comes down in front of the x, so we get minus 2. And then the power gets reduced by 1, so that's really to the power of 1. So that's where the minus 2x comes from. It's really minus 2x to the power of 1. And then the 4x, we just cancel out the x to get 4, and the constant 5 becomes 0. So the derivative is minus 2x plus 4. We'll cover this in great detail in calculus. Therefore, the turning point occurs when the derivative is equal to 0. So we let minus 2x plus 4 equal to 0, and we solve for x. So the plus 4 comes over and becomes minus 4, and dividing both sides by minus 2, we get x is equal to 2. And then subbing in 2 into the original function, so not into the derivative, into the original function, which is minus x squared plus 4x plus 5. We get minus 2 squared plus 4 times 2 plus 5, which is equal to 9. So a much quicker way of getting the turning point. So 2, 9, again, is our turning point. So we will cover all of this again in calculus, but I just want to link it in now while we're on the topic.